So here's a solution to Lesson 2, Question 9. A mountain climber free falls for 10 meters, reaches the end of his safety rope. The rope stretches and stops the climber in 1.25 seconds. So first thing I need to notice, this 1.25 seconds, that's how long it took to come to a stop, not how long they fell for. A says find the final speed at the end of the free fall. All right, guess it wants me to find VF. I'm going to assume VI is 0. I've never seen a rock climber take a flying leap and sprint into their fall. They're in free fall, so I know A is negative 9.8. And D, because I'm doing kinematics, I'll have to call it a displacement. D is negative 10. If I want to find VF, I think I'm going to end up using VF squared equals VI squared plus 2AD, although VI is 0, and then how do I get rid of a squared? Square root. It's going to be the square root of 2 times negative 9.8 times negative 10. And if you crunch the numbers, you will get 14 meters per second. Now, if they had said find the velocity, I would call that 14 negative. They said find the speed, so that means they're only concerned with the magnitude, not the direction. So who cares? B says write a net force equation. This is a job for a free body diagram. I'm going to do that right here. What are the forces acting on this climber when the rope begins to stretch, when we're slowing down? Get the obvious one. Well, we're going to have gravity. Which way is the climber moving? Well, the climber is moving down, but the climber is slowing down. So which way is the climber accelerating? Up. Which way must there be a larger force? Up. What force is that? That's tension. So who's winning? Tension. Minus who's losing? mg. That equals ma. So that's where that equation came from. C says find the acceleration when the rope brings the climber to a stop. Okay, now it wants me to find A. My first thought was maybe I could just divide by M, but the problem is I don't know tension. In fact, part D wants me to find tension. I said maybe I'm going to use kinematics because I still haven't used this 1.25 seconds. So I said, okay, I know T is 1.25 seconds. Comes to a stop. I know VF is 0. VI must have been 14. VI must have been 14. So I can go A equals VF minus VI over T. I'll get 0 minus 14 all over 1.25. And if I crunch that, I'll get 0 minus 14 divided by 1.25. And I get negative 11.2. Now the negative here is telling me that I'm slowing down. But then to do part D, find the tension, how would I get the T by itself in this equation? I would plus the mg over. I'm not going to put the negative in for A. I'm going to get ma plus mg. It's just going to be the mass, which I'm pretty sure they told me, 75, times 11.2 plus 75 times 9.8. Not going to put the negatives in here. I take care of negatives with my winner minus loser here. And I'll get 75 times 11.2 plus 75 times 9.8. And, typo, Mr. Dewick. And that's where the 1,575, or I think I wrote it as 1,580 newtons comes from. So I would argue every section of this question, totally fair game, because there's nothing new there. Will I give you one quite with this many steps on your test in Physics 11? No. Physics 12, what I would probably do is give you the first part of the question and then simply say, find tension. And I expect my kids to realize, well, to find tension, I need to find acceleration. To find acceleration, I need VI. To find VI, that's going to be VF in the free fall. Hope that helps.